This is the homework for the distance formula assignment that was given out on Thursday, April 18th. So let's go ahead and review here that we're going to find the distance between these two sets of points right here. Using the formula, we'll say x for the distance equals the square root of y2 minus y1 squared plus x2 minus x1 squared. Okay? So it's important that we go ahead and label appropriately what our x2, y2, and so forth is. So here we're going to have our x1, we're going to have our x2, our y1, and our y2. So then we just go ahead and plug it into our formula. y2, which is negative 8, minus what we have for y1, which is negative 3. Okay? We're going to square this and add it to what we get when we subtract x2, which is 1, minus what we have for x1, which is 4, and square it. So again, because we know that a negative times a negative equals a positive, and don't forget, we do our parentheses first, and then we'll deal with the exponents. Please excuse my dear Aunt Sally, right? So negative times a negative is positive, so we're left with a negative 8 plus 3, okay, and we're going to square this, plus 1 minus 4 is negative 3 squared. Okay. So now negative 8 plus 3 is negative 5 squared plus negative 3 squared is 9. Right, so we have now the square root of negative 5 squared, which is 25, plus 9, which equals the square root of 34. Okay, so again, if we go back to the calculator, and we know how to approximate this, well, we can go ahead and put it into the calculator as second x squared, and then we have 34, close parentheses, and we have 5.8. Okay? So this next one, again, x1, y1, x2, y2. Okay, so we have our radical here, and we're going to take our y2, which is negative 8, minus what we have for y1, which is negative 7, square it, plus 4 minus 0 squared. Okay, so again, we have a negative 8. We have negative times negative is positive, so we have a negative 8 plus 7 squared plus 4 minus 0 is 4 squared. So negative 8 plus 7 is negative 1 squared plus the 4 squared we already have, which equals negative 1 squared is 1, 4 squared is 16, and so we're left with the square root of 17. Okay, so again, we can go back to our calculator and we can find out what this is. We have 4.1. Okay, So again, next one, y2, x2, y1, x1. Take our square root, y2, negative 6, minus what we have for y1, which is negative 7, plus x2, 1, minus what we have for x1, which is negative 6. Okay? So again, negative times negative is positive. Negative 6 plus 7 squared plus 1 minus a negative 6, which is negative times negative is positive. 1 plus 6 is 7 squared. So negative 6 plus 7 is 1 squared plus 7 squared is 49. And so 1 squared is 1 plus 49 is square root 50. Alright, so again, we'll come back to the calculator. And we have and we're left with 7.07. Good. Alright, so the last one, I'll do this in black. y2 minus y1 plus x2 minus x1. So negative 7 minus 6 is negative 13 squared plus negative 1 minus a negative 3, which is negative 1 plus 3, which is going to equal 2. Alright, let's go over here to the calculator again. And we'll see that negative 13 squared is going to equal, it's going to actually equal, so we do this right here, with negative 13, so that it makes sure that it keeps it with the square, is going to equal 169. Plus 4, and we get 173, which equals 13.2. Okay, so this is how we find the distance between 2 points. Let's go to the graphs. Okay, so the graphs here we're going to use, we can go ahead and pull the points. All right, so we have, let's say we looked at the ordered pair for number 5. So the ordered pair for this point is going to be negative 5, 4. Okay, and then for this point we have negative 2, 5. Okay, and so we can do what we did before. We can go ahead and label our y2, y1. So if we did that, we would have y2, which is 5, minus y1, which is 4, squared, plus x2 minus what we have for x1, which is negative 5. Right? So 5 minus 4 is 1 squared, plus negative 2, negative times a negative is a positive, so it's be negative 2 plus 5, which is 3. And so now we have 1 squared, which is 1, plus 9, which is 3 squared, equals square root 10. Okay, and so we come back here again to the calculator, and we see that the square root of 10 is 3.16. So we'll say 3.2, round it up. The other way we can look at this, if we looked at number 6 here for a second, is using the Pythagorean theorem. Okay, so let's say that we're looking for the distance between these 2 points right here. Let's say we go ahead and draw our triangle. Okay, so our triangle, if we looked at distance, what we were talking about earlier today, from here to here we have 1, 2, 3, 4, 5, 6, 7, 8. So our distance here is 8. And here on the x-axis, the change in x's is 1, 2, 3, 4, 5, 6, 7. Okay, so if we're looking for this side right here, and we know this forms a right triangle, then using the Pythagorean theorem, we say that this is our C, this is our A, this is our B. So we can plug that into our formula for the Pythagorean theorem we know to be 7 squared plus 8 squared equals x squared. So 7 squared is 49 plus 8 squared is 64 equals x squared. Alright, so 49 plus 64 is 113 equals x squared. We'll take the square root of both sides to cancel out the square on the x, and we're left with x equals the square root of 113. Which in fact, if we look at our calculator, it will equal 10.6. Okay. Now this one's a little bit easier because we're looking for the distance between the 2 points, but because they're not on a diagonal, this is pretty easy to determine that the distance between these 2 points, the distance between 5 and 2, is just 1, 2, 3. Not bad, right? On horizontal lines we can do this, and even on vertical lines we can do this. We just can't do it on diagonal lines. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. That's the distance between this point and this point. Alright, last ones. Let's go ahead and get a little bit more practice with the distance formula. So the ordered pair for this is 2, 2. X is 2, y is 2. The ordered pair for this is x is 3, y is -4. Okay. So again, plug it into the formula. y2 minus y1 is -4 minus 2. And again, remember, it does not matter which one we label as y2 minus y1 or y2 minus y1. Either one can fit the bill. It'll still come out the same way. So 3 minus 2 for the x2 minus x1. -4 minus 2 is -6. 3 minus 2 is 1 squared. So -6 squared is positive 36. Anytime anything is squared, it comes out positive, plus 1, because 1 squared is 1. So we get the square root of 37, which is equal to 6.1. Alright, and so for the last one, our ordered pair here is going to be x is -1, y is 0. And over here we have x is 5, y is 4. So we have, let's say this is our y2 and this is our y1. So we have 0 minus 4, again showing we can do it any direction we want, plus x2 minus x1. We just have to make sure that we keep consistent, that if we start here with the y1 or y2, then we have to start here with the x2 as well. So 0 minus 4 is negative 4. We're going to square this, plus negative 1 minus 5 is negative 6 squared. Negative 4 squared is 16, plus negative 6 squared is 36. And this is going to give us the square root of 50, which I think we had just earlier when we were looking at this one. So it's 7.07. Here's your homework.